less than, loop, equal to, no loop, greater than, flat side. Those are the things you need to know if you're going to graph a limacon. So let's practice. If you were given this without a calculator and you were asked to graph the limacon r equals 1 plus 2 cosine theta. A is 1, B is 2, A is less than B, I have a loop. I have plus, so it is the positive end of the x-axis is my major axis. So although this looks terribly difficult, it's not. Here's my pole. Here's 1, 2, 3, 4, 5. Here is the positive end of my x-axis. Here is my y-axis. There's 1. There's 1. I know that I'm going to have that. I know that I'm going to have a loop that is b minus a. So I'm going to have a loop that starts at the pole and has that distance. I know I'm going to go from the pole along the major axis a distance of a plus b. Done. There is r equals 1 plus 2 cosine theta. So again, lots of clues given to you in the equation itself. One more before we move on to roses. R equals 1 minus the sine of theta. A equals 1, B equals 1, minus sine of theta. No loop. A equals B. X-axis, y-axis, 1, 1, 1, and 1. The negative y-axis is where the majority is going to lie. I am going a distance from the pole along the minor axis of A, and I don't have a loop, and the distance from the pole along the major axis, the negative end of the y-axis, is A plus B. There's my cardioid, there's my heart. Not difficult at all. Now we're going to talk about roses. Roses are the second type of polar function that we're going to have to deal with and use calculus on. I'm going to go through this rather quickly because, as it turns out, roses are often, not always, but often calculator active questions. So we don't have to worry too terribly much about being able to graph these by hand. I will again point out some things from the function rule that allows us to determine what the graph of the rows might look like, even though, again, as I say often, we don't have to graph these by hand. Notice that on roses, we have r equals a. There is no plus or minus. We go directly to either sine or cosine, and then we have not just theta, but we have n theta. So if there is no plus or minus sign, we're not dealing with a limacon. We are dealing with a rose. N plays an important part in our rose. If n is an odd value, we have n number of petals. If n is an even value, we have 2 times n number of petals. Here, we have 4 petals. I have heard these referred to as petals or leaves. Often, each of these is referred to as a leaf or leaves on a rose. So we have 4 of these. 1, 2, 3, 4. Since we have 4 leaves, that tells us n was 2. So I know I'm dealing with r equals some value of a, and either sine or cosine of 2 theta. Since all of the leaves are on the axes, that tells me this was cosine. Since my leaves intersect the axes at a value of 1, that tells me that a is 1. So the equation for this graph is r equals the cosine of 2 theta. Here, since there is a leaf on each of the axes, I know again we're dealing with cosine. Since each leaf intersects the axis a distance of 1 unit from the pole, I know that a equals 1. So I'm dealing with 1 times the cosine of, and I have 8 leaves, therefore I know that n is 4. Because I will always have 2n leaves when n is even. Here I do not have a leaf on an axis. None of the leaves are on the axes. That tells me this is sine. I have 4 leaves, therefore I know n is 2. So the equation for this rose is r equals the sine of 2 theta. The distance from the pole to the center of each leaf, regardless of whether it is on an axis or not, will be the distance of a, the coefficient to sine or cosine in your equation. Again, I don't have any leaves on an axis. That tells me this is sine. I have 8 leaves. Therefore, I know 8 is 2n, and n must be 4. This is r equals the sine of 4 theta. I do have 1 leaf out of the 3. Here n is odd, so I have 3 leaves, so I know n is 3. I do have 1 leaf on the x-axis. That again tells me I'm dealing with cosine when n is odd. So this would be r equals, the distance here again is 1, so this would be the cosine of 3 theta. I do have 1 leaf on the y-axis. That points me to sine when n is odd. A again has a value of 1. This is r equals the sine of 3 theta. What gets a little confusing about roses is where exactly the leaves are. Sometimes I could have, when n is 3, I could have a leaf on the positive y-axis, and the other 2 leaves would look here. That would point me to the fact that it's sine. It would point me to the fact that n is 3, but it would be difficult for me to actually draw this graph by hand. We will do some practicing of drawing roses by hand, and there are some landmarks that we will look for, but by far we need to practice roses, entering roses, looking at roses on our calculator. So again, n is odd. I do not have a leaf on the y-axis. I do have one on the x-axis. A again is 1, so this is r equals the cosine of 5 theta. This would be r equals the sine of 5 theta. So let's attempt to graph one by hand. We'll do it fairly quickly. There are some landmarks of things that we can do. This is cosine. So I should have a leaf or two on the x-axis. N is 2. N is even. It is 2. I should have 4 leaves or 4 petals. A is 2. I should intersect the x-axis for certain a unit of 2 away from the pole. Since we have 4 leaves, I know that that is the graph of my rose. So that finishes up our work with polar functions, our non-calculus work with polar functions. Come to class next time and we'll work some homework problems.